Hi everyone, this is James Mundia, and this is a video I've made to showcase a project I've been working on to prepare for some upcoming job applications in the space of cloud solutions and cloud architecture. So before we dive into the demos and the technical sort of deep dive, I should say that there are parts of this video that some people might not find relevant to viewing. So there are comments in the description box below that will actually allow you to link to or click on and access different parts of the video if you want to only know about the technical backend or lessons learned, etc., etc. Along those lines, the code will be available on GitLab. It's available now, but it's not meant to be deployed as such. This is really just a demonstration of the process as a whole. You'd have to do a little bit of work on the back end of your AWS infrastructure to really make it relevant to you. So it is a work in progress. But that being said, let's get to the project overview. I'll make it short and sweet. This is a demo application, a prototype application for a fictional national security agency that will allow deployed agents that are not deep cover. So these are people that are in plain sight to let headquarters know what's going on in their environment wherever they're deployed. So as you can see here, we have a normal check-in, a yellow check-in, and a red check-in. What these will do is trigger Lambda functions via API gateway, and then those functions will write to a DynamoDB database, but they'll also be delivered to queues actually before they get to DynamoDB, so that in the instance of somebody being in a red situation, that will eventually trigger separate operations so that, okay, this person's in a red situation, we need to deploy agents to pick them up, etc., etc. Again, working off of a fictional national security situation. And so from a technical standpoint, this is a serverless application that is using Python for the backend Lambda functions and Vue.js for the front end. And this demonstration, this video is really more about the back end. I'm looking to work in that environment more so than I am being a front end developer. So as you can see by just kind of the rudimentary way the front end looks, that is my focus at the moment. So hopefully that's not too distracting. These are stock images. Obviously, there can be a lot more done with the design and layout, but that's not the focus of my current job application process. So let's dive into how this actually works. Okay, so now we're in VS Code, and I thought that I would just go over the login process. I did demo that. And what you have here is the classic V model to allow users to input information, and then V on click that allows events to actually happen in the DOM. And then what happens is that actually gets passed to an object, which then is passed into Axios, which makes HTTP calls. And you can see here that we're using environment variables. So this way we're not committing code that has secrets or things that could be exploited. And once that's actually sent, the body of the request is actually the username and password information. And then that triggers this logic here, which utilizes not just Axios to get a response from the API gateway, but and the Lambda function that eventually calls, but it also commits some certain items to the store. The Vue store is Vuex. I guess it's modeled after Redux, which is popular with React users. And so this way, the browser will have access to certain things like username and the user status, right? So we're setting the login status as someone who's logged in, and then we're also doing something here where we set the role, and we'll go into that more when we jump into the Python Lambda function. So for purposes of linting, I've actually commented out some of the console statements, and I think that actually is consistent with what you'd want in production so that people couldn't get a peek into how the code is working itself. So that's the login front end. Now on the back end, I'm going to go ahead and open up the Python function. This is a Lambda function, and the Lambda functions are actually I don't know what that message was. The Lambda functions are actually deployed using the serverless framework and not the serverless application model that is the AWS, branded way of deploying serverless applications. And so what we're doing is we're just importing what we need. There was some testing here, as you can see, that we're not using right now for the development environment, and we'll get into the different environments. As you can see, we're in develop of the branch right now, or in the develop branch, I should say. So again, all we're doing is we're just sending the information, and then we're doing some checks against the DynamoDB database. That DynamoDB database is a environment variable. So again, trying not to commit secrets or things that could be exploited to code. And then based on the response from DynamoDB, there's some logic that occurs. Essentially, we're just checking to see if the user exists. And if the user exists, we're going to check the password. And then if that's all good, we're going to check the role. And then we'll return values based on the role that is returned, or we'll return an error message. And I'll not allow them to log in. So now that we've gone over the basic login workflow with Vue.js on the front end, I think it'd be appropriate to talk about the back end and how this all gets wired together. So we're using the serverless framework. That is the actual framework, I guess, serverless with a capital S. And what it allows us to do is to define functions and the parameters of the functions and deploy them via CloudFormation. So you can see here in the provider block, we have the actual cloud service that we're going to use, the runtime and the region, and then a parameter for the role. What we've done throughout the entire serverless YAML is in an attempt to prevent developers from having to commit secrets to source control, we actually use the systems manager parameter store. And so these are predefined parameters that have already been populated that the function will reference once it's deployed. So this can be scripted if you want it to. In this case, for the development environment, they've been pre-made, but of course you do have control over how you deploy these parameters. That you can interact with the CLI pretty easily and create the parameters needed and then reference them in your code. So we have a number of functions here, and these all are linked up to the API gateway, or when necessary, the simple queue service. So we'll focus on login here, which just basically makes a post to the login address on API gateway, and it sends the information in the request, and then there's a response from the Lambda function. And again, there's a user table that is referenced, to make sure that, okay, is this person actually authorized to log in here, and that is in the parameter store as well. One of the things that I'll talk about in the lessons learned is how this can be probably fixed changed to use Cognito, and that's an issue that will be dealt with in the code. As I said, it's a work in progress. But as of now, you have a DynamoDB table that is encrypted at rest that will be referenced whenever somebody makes a login attempt. And there's obviously some security aspects there to think about, and then we'll get into that again in the lessons learned. So I think the meat of this demo is going to be about the check-in process. So we've got a split screen here with the YAML file that defines the actual functions. And then this is on the right side, the view file that is serving the front end for agents that are checking in. So I'll just highlight here that we have buttons that call various Axios calls based on which button you click. So on the top here, we've got the green check-in, and then we have some JavaScript methods down here. And the green check-in will actually prompt this to happen, where the status will be green, obviously, and then we actually have a sort of a stock agent name here, and a timestamp, and then a GUID, which will allow us to sort things in DynamoDB, filter things in DynamoDB, and then we actually sort by the timestamp in DynamoDB. Again, we're using environment variables here, and this allows us to, again, not commit any secrets to the code, and it sends the information from the previous call, and then it does return a response, and that's interpreted by the program itself. The same follows for yellow and red, and again, we have some made-up names here for the yellow check-ins. As the project progresses, obviously, it will take the actual variable that is the signed-in user as the agent name, and things like location, etc., as it grows. But this is just, again, a prototype to demonstrate, okay, how do we actually allow for agents to let us know what their status is? So that corresponds to the function here, which is the check-in function. It's a Python file, and again, we're making a post, and we're using Lambda integration and allowing all IP addresses, and then we can actually open up the Lambda function itself. It's pretty simple. It's using Boto, again, because it's Python 3.6. There's an environment variable for the queue itself, and all we're going to do is take the event, and we're going to dump the event to the DynamoDB table. And so what we'll do next is examine what did those events actually look like in the AWS backend. Okay, so before we dive a little bit deeper into the backend of the development environment in the console, I want to just correct an error I made in the last part of the video, which is actually stating that the check-in function writes to DynamoDB. It actually doesn't. It writes to a queue, which then triggers two Lambda functions, one of which processes the information and sends it to DynamoDB, and that's this function here. And you'll see there's a lot of commented out code, which I'll get into later in the video here. And there's also another function that will process the events from that queue and will actually work with Kinesis. And so we'll get into that when we talk more about observability. So anyway, that's just something I wanted to correct. But now let's go into the console, and we're going to actually, for demonstration purposes, it's kind of interesting. I'd wanted to just show the polling for messages in the SQS queue. But for some reason, and this might just be native to SQS, when you have functions attached to your queue that trigger, your queue triggers functions, you actually don't see the messages, or at least I haven't been able to. So that might just be something that's native to the service. So to kind of demonstrate the actual workflow, we'll just use DynamoDB, which is where they end up anyway. So you can see we've got some test check-ins here. This is in the development table and based in US East 1. And so what we're going to do is we've got 12 items in here. I've got the development application loaded up. I'm logged in, and it's being hosted in CloudFront and US East 1 as well. That's the backbone of the development environment is US East 1. And we'll just go ahead and generate some events here. And as I said, this is not a demo on how great I am at front end because I'm still developing my skills there. So normally you'd have some logic here that would say, okay, you checked in once, so now we remove the option to do other check-ins, and you can't check in for 8 to 12 or 24 hours. So that's an improvement that can be added in. We'll get to that at the end of the video. So we've just created 3 check-in events. They should have gone through the queue, and we'll see, and now we've got 15 items instead of 12. The primary key is actually the GUID, so we can separate events, and then we sort things by timestamp. These are 3 fake agent names that have been created, and again, on the front end, we can add in some logic that basically takes the username that's logged in and actually delivers that, or user ID or something. And then this way, we can it'll be functional. But for the development environment, we're just trying to get everything wired up and eventually take it live. So that's a look at the actual workflow itself. We can dive into, I will open up the process check-in Lambda function here. And again, I'll return to this commented out code and random comments that are in there. But essentially, we take the event from the SQSQ. We do some transformation using the AST literal commands. And then this is actually also using Boto and connecting to the DynamoDB table via an environment variable. And then we just call a simple put operation that just puts the agent name, the unique ID, which is generated actually on the front end, Unix timestamp, and then the status that's reported. So again, just something to demonstrate like a basic event-based architecture for this use case, which is doing a status report. One thing that we haven't wired up yet, or that I haven't wired up yet, is we do want to have the ability to submit reports, something a little bit more detailed with more intelligence. Hey, this is a person I saw, they've been going to this place 6 or 7 times, meeting with these people, I think we should keep an eye on them. And then even eventually document uploads. So again, those are front end and back end improvements that will be added in as the project progresses, because I do view this as a living portfolio, not just a here's what you get. So that's just a quick look at the core of the back end. What we'll do next is we'll take a look at the foundations of observability, which is the final sort of technical requirement for this mock National Intelligence Agency. And then we'll dive into where the project's going and some lessons learned. So I think it's important, now that we've established that we can actually check into a DynamoDB table from the front end of the application, I think it's important to discuss, what do we do with that data? So, okay, you've checked into DynamoDB, there's a GUID, there's a timestamp, there's a status, and there's an agent name. So what happens after that? So wired into the front end of the code is actually some logic that handles what happens when you log in as an admin, as I have here, and when you log in as just a regular user, is the way that it is being declared in the code. So when you log in as an admin, it actually returns a different status code in the API gateway response, and that will actually give through Vue.js a different front end, and so that's pretty easy to wire up in Vue, and that's the front end you get here. Again, it's not been stylized in any impressive way yet, but it does allow us to have the basic functionality of saying, all right, people have checked in, I want to see who checked in. So when we do this get check-ins operation, it will list all the check-ins that are registered in DynamoDB. This can be paginated, which is relatively easy in Vue.js. We could also wire some logic into Lambda that basically says, okay, anytime this call is made, only return the last 5. You could have different buttons to say return all check-ins, return check-ins from the last hour, and because they're time-stamped, this is pretty straightforward. And looking at it on the code side, the check-ins component here in Vue is pretty straightforward. Very simple for loop, and we've got like using the Bootstrap, that's the name of it. Using the Bootstrap Vue package, we can stylize it a little bit. And again, all we're doing here is we're calling a method called getCheckins. It makes an Axios call, which is a great plugin for making HTTP calls. It uses an environment variable, so we keep that stuff keep secrets out of the source control. And it essentially stores that into the Vuex store. And it says, okay, we're going to set the check-ins that have happened using the data that's been returned. And so that data is available. And then this computed value is a way to see when data has changed. You can actually see it in your application on the front end with Vue. So another kind of example of how you can really use Vue, even though it's really just for building the user interface with using computed methods and, computed properties and methods. You can interface it with any backend service provided you have access to it. So that's just a quick look into what happens when we want to access the check-ins, and there'll be a diagram in the documentation as well. Let's talk about the foundations of observability that have been built into this development environment and will obviously be a requirement for the production environment. So the basic workflow is that when a check-in event happens, it hits an SQS queue, as we talked about in the last part of the video. And that SQS queue also triggers this capture check-ins function. And what this does is it just takes the check-in event, and that actually gets fanned out to a different function, which is this one, and it prints the body of the check-in event. And there is a Kinesis stream subscribed to the CloudWatch logs for this function. So the Kinesis stream is just going to capture every CloudWatch logged check-in, and it's going to get the body of the check-in. That Kinesis stream will then trigger this process Kinesis function, and this gives us the ability. This gives us access to the actual data itself. It's gzipped, obviously, so it needs to be decoded, and then we can put it where we want it. If we wanted to put it into S3, which is seems to be more popular, or we could transform the data and put it into DynamoDB. It just kind of depends on the requirements for the use case. So again, you can see here with this code, and this will all be available on GitLab. I should have mentioned that earlier for people that want to take a look at it. But you can see here that we're sorting out the requirements for the data structure, which I'll get into later on in this video. And eventually that will allow us to do things like, okay, we're going to put this object in this bucket, and the log time is going to be the key. So as I said, we have the foundations for observability, and then we can use that for things like capturing logins, capturing API gateway events, and having a real insight into what's going on in the application. So this is something that is a feature of the development environment that will eventually be a requirement across the board. Okay, let's talk about the CI/CD workflow for this project. It's a requirement, a big requirement for this portfolio, and obviously a big requirement for this sort of mock government agency that this project is geared towards. So that was a core requirement for the entire development process, that there's to be as little or none of any manual deployment of infrastructure, and it would need to be something in a that could be done in a multi-region way, which we'll get into as we talk about the CI/CD pipeline. So it's branch based, and we're using GitLab's CI/CD feature to deploy this, which I think is a really handy feature. It was something that I've wanted to work with in this type of project for a long time. And so the develop branch actually has a little bit of a different structure than the master branch, which was going to deploy to production. So the first thing that we do is we build the development branch. And this is the YAML file that is standard for all GitLab deployments, or sorry, GitLab CI/CD setups, where you, excuse me, assign an image and you give it a stage name. And then you can also start to have sort of variables that affect what happens. So in this case, we only want to build the develop branch when we push to develop. That's it. Then we run through a script that installs serverless on this image, changes directories to where our actual functions are, and where the serverless.yaml is, which defines the functions, and then it deploys it. There's a print command here, and what that does is just gives a little bit of information about the job that was just run. And I have this in here for the development environment and for just working on it one-on-one, so that when a job is running, I can see if, did it print out the right stuff. As this GitLab project goes public, that will probably not be the case, because that could expose some secrets, and they don't need to be out there. Probably the most important part of the, let me get that out of the way, the most important part of this sort of workflow, because we're working with a serverless front end and back end, is how do you get things to talk to each other when stuff is being built, and so you can't hard code, for instance, the API gateway endpoint. So that, of course, you have to do environment variables. So this is something, again, that will come in later when we talk about lessons learned. But in this case, what happens is we have a script called get endpoints, and that script is coded in the local environment, and it's coded to essentially just get the API endpoints that were just created or updated. And I can show that here in the video. And so again, all we're doing is we are just doing a basic SLS info. Hey, what was just deployed, and then we send that to the .env file. We do some sed commands to conform this to the view environment variable requirements, which are that everything starts with view underscore app in uppercase, and then you can fill in the variable however you want it. So that's the script that runs. Once that script is run, then we copy it into the core directory for the application, which is where it needs to be for Vue to recognize it. And then we change into that directory and we cat it. Again, this is something that will be commented out when this code goes public, because that has a ton of secrets. And then we run the install job, and then we build the project. There is a standard Vue folder that is a distribution folder, and that is actually what holds the code that's going to get deployed. This is the deploy development stage, and all we're doing is using a basic Python image. We are grabbing the AWS CLI, and then we're pushing to an environment variable that is set within GitLab. And so what's great about this is that the AWS credentials that you provide as environment variables in the GitLab CI/CD setup are used here. So you don't even have to write any IAM rules or do anything crazy IAM gymnastics to be able to just send into a bucket that you have permissions to. So in this case, I just created an IAM user that is solely for the deployment, the CI/CD part of the project, and all it has access to is what it needs to deploy this. So in this case, really it just needs to be able to make basic API calls or CLI calls and talk to the bucket. And so the process is pretty similar for the build. Again, we're only doing it when there's tags. So it's a new release, and we're gonna deploy it. And then we do the same thing. We deploy it to production, again, with just a basic Python image. So that is the CI/CD pipeline using GitLab. It's perfect for this because as the project evolves, there's also the need for multi-region, and you can set that up based on these CI/CD settings within GitLab. And as you can see, it's pretty scriptable, so you can really get very complicated with your deployment requirements. For instance, there needs to be a test stage here that we don't even build the job unless the test is run, and that's again for the lessons learned later on in the video. Okay, so that was just a very brief overview of a very simple project. And what I'd like to stress here is that while this is a portfolio project for some upcoming job applications, it is going to be something that is a work in progress and continues to grow through the process of mastering all of the, or as many of the AWS services as I can. So some upcoming features that you can expect in the next, well, starting, they're already in progress right now, I guess, is obviously better authentication. We're just hitting a DynamoDB table with text. Cognito does integrate pretty well with Vue.js. There's even some actual NPM modules that can handle that. So that's priority number one, especially as we look to deploy to the development environment. Timing logic for check-ins. I touched on this a little bit earlier. We want to have the ability to say, okay, you checked in, so you can't check back in for 8 hours, or and maybe even have some logic. Well, if it's I need to change my status, then I have a different authorization process, and that can be achieved using just the fundamentals of Vue.js, the Vuex, which is the store, which then would be able to check a DynamoDB table via Lambda to say, when was the last time this agent checked in? Well, they can't check in again. And that can actually be done on the mounting of the Vue.js instance itself. So as soon as that page loads, it'll check this and it'll return, well, you're not eligible to check in for another 7.5 hours or whatever. Safehouse is actually what inspired this whole project, and it ended up incurring too much technical debt with the IoT part of it. But the idea is that while we have Culbreth, which is what I just demonstrated, which is for agents that are not deep cover, they're sort of working undercover, but they're not deeply embedded in the environment that they're in. That's what Culbreth is for. They still have access to a computer, and they can just pretend that they're working for this Culbreth management group, or Culbreth Partners is the name of the fake group. Safehouse would be more for embedded agents that really can't access something like that without jeopardizing their mission. So it would be IoT based with Raspberry Pi type devices that are deployed either before the agent gets there or by the agent, that would allow them to quickly send their statuses via a secure line, something like a private link, so that nothing's going over the open internet. And that would just involve an IoT device that makes Lambda calls, and it's sent to a queue, and that kicks off other actions as well. Snoop would be the actual delivery of intelligence, just documents, pictures, just general reports, and that's again very easily done through the core elements of the Vue.js framework, Lambda and DynamoDB, and you could even obviously add S3 in there as well for the storage of documents. Moneypenny would be for systems health monitoring and reports, so that's the observability section that we talked about before, and expanding on that to even eventually using a higher end product like QuickSights or Redshift to really have insight into what's going on in the environment, how many people are checking in, how many API calls are we consuming, and then that also will inform infrastructure decisions. Kittredge is named after the sort of bad guy in the Mission Impossible movie, and that's for chaos engineering, essentially using the Netflix approach to, have a established system that breaks your infrastructure and to see how quickly it can recover, which I think would be pretty valuable for a national security application like this. Borg would be a machine learning application that would ingest intelligence information and learn what's useful and what's not, and be taught that by the people that are delivering it and the people that are ingesting it, so that you can actually start shaving time off of coming up with intelligence insights. And lastly, you have Winnie, which is a honeypot. So it's named after Winnie the Pooh, who likes honey. And this would be the actual ingestion of uh, sort of malicious traffic to see where it's coming from, to see if there's actually attempts that are being made to infiltrate the system. And the way that that can be achieved is by setting up some sort of honeypot. Maybe it's an account number that gets exposed, on purpose by accident, quote unquote, and to see, who is trying to connect to it, what regions are they coming from, does this actually represent a threat that we should, take proactive measures against in our production system? So it kind of, again, gives you sort of like a template for how you would move things forward in your production and development environments. So that's just an overview of sort of the direction this is going. The main purpose, again, is to master as many AWS services and workflows and use cases as possible. And so I've chosen to use this national intelligence example. It's kind of a fun one to do, but I think that there are applications here, for other use cases, whether it's retail, healthcare, just the idea of a quick and safe delivery of important information that cannot be, missed. So that's just a look at where the project's going. Up next, we'll wrap things up just talking about lessons learned and sort of like the plan for going forward from a personal perspective, which is, a reflection for me, but it may be interesting to people that are, trying to find out a little bit more about what I'm doing with these projects. Okay, so to close things out, just wanted to touch on a couple of lessons learned and reflections through this project that I think are kind of a good insight into my working process, but also where things are going. And I should note also that this code, again, will be available on GitLab. There'll be a link in the description of this video. And it will probably not be open source as it is right now. I'm sorry, open source that would allow people to contribute to it. But there will be tracking of the issues and the upcoming features, that if somebody wanted to keep in touch with what's going on with the project or suggest things, and maybe eventually contribute if they're so interested, then so be it. So anyway, the biggest takeaway from this project and is the idea of really understanding data structures, and not data structures as an abstract concept of you need to know about every single possible data structure, but just the data structure of what you're dealing with. So the early struggles, especially once we started making API gateway calls that would trigger a Lambda, is how does Lambda see the text or the data that is being sent as an event through API gateway, and how does it respond, and what is the format of that? So, that was something that once that became clear, I had to, really grind away at it for a couple days to figure out how to get things to talk to each other correctly. That really took the project in a new direction, where I could really, to use an expression, move fast and break things, but then also fix them, because once the data structure is known, then getting the information you want from certain calls or functions is a lot easier. So this was really interesting, because you're working with a Vue.js, so it's JavaScript front end, and then Python. All the Lambda functions are written in Python. That was a personal requirement, as I wanted to level up with Python in general. So getting more comfortable with how data is structured along those two languages and making them talk to each other was a real big win here, and something that's going to be important going forward. Along those lines, I also really understood the power of serverless applications regardless of what language you're using. And so there probably aren't a lot of example projects or production projects that are using Python and Vue.js, despite both of their popularities. But when they're coupled with Lambda, I actually found it extremely straightforward. And the architecture is so simple because it doesn't need servers. The database itself is serverless, and it's also um, on-demand capacity. So you're really keeping costs low for development, but you're still able to achieve pretty much anything that you can code in Python and in JavaScript, which to me, I don't think there's any limit to what you can do if you're familiar with those languages. Um, Going back to the data structures, this next point with tutorials versus grind time, there were times where I fell into the trap of doing too much of one versus the other. And so sometimes I would just be ingesting tutorials and blog posts and not making any progress and kind of sticking with it. And then there were other times where I would just try to grind through a problem, and rather than just, go and look and see, well, maybe somebody's been through this before. So you have to have a balance there, particularly when you're working with things that you haven't used before. So the best example for me in this case was Kinesis, something that, is a relatively new AWS service, but also something that was extremely new to me. And so the concepts I was familiar with, but it would have really taken this project much longer to get to a proper development stage without actually going and doing some tutorials on Kinesis and playing with things, as opposed to trying to figure it out on my own. And of course, with the data structures, what I realized was the opposite, that I really needed to just work through how to structure data in a basic way in Python that's readable by Lambda, and vice versa. Flexibility is something that I think is the only way this project actually kind of got to a point where it is now, where I can share it. Originally, like I said, this was going to be an IoT-based solution for deep cover agents, but the IoT initial work with a Raspberry Pi that I had purchased was an unbelievable amount of technical debt, and I believe potentially just because of either improper setup on my part or not using the right documentation. So I just had to switch it over to, well, we're going to have to make it web-based now, and that's sort of the direction that I took. Sorry. Work rest ratio. It's another kind of balance focused reflection. There have been some days where I'll just code for seemingly hours and hours, and the time just flies. And there's other times where I can't seem to get a half hour or an hour of code going. And I think it's important, whether on a personal project or on a professional project, to manage energy and manage self-care, so that you're actually able to complete things. So there are some times where you just have to work through it, but it doesn't have to be every single time. And then on the other end of the other side of the coin, if you go 2 or 3 days without touching any code or doing any development, maybe you need that rest, but you don't want to overdo it, and then it's going to be hard to get back into the swing of things. This is one that I think was really surprising to me, is that a lot of the things that I thought that I was going to have to do manually, AWS already does, and does it pretty cheaply and pretty easily. So Kinesis is the best example. I thought I was going to have to write some very complicated Lambda functions to actually get the Kinesis stream to give me something useful in S3 or DynamoDB. But you can actually link a Kinesis stream directly to a Lambda function, and the same is true with SQS. So all you're doing with SQS is basically saying, when something happens in SQS, trigger this function, and that's extremely powerful. It shaves a ton of development time off, and it makes you kind of think about, what else can I do now that I know that AWS has something that's reliable, managed, and affordable that can do it for me. And so lastly, there were periods with this project where I was very frustrated because it was maybe a service I didn't know how to use, or it wasn't working as it should. I used the serverless framework to deploy, and there are a lot of quirks with that, and sometimes there's even lag with the functions that you've deployed developing. So you deploy a change, it redeploys the function, but it doesn't change it. And so you do a test, it doesn't work, and you're like, I already fixed it in the code. What happened? So that was a real opportunity to understand that just because something goes wrong doesn't mean that the project is doomed and you're not going to get a job, or this or that, or the client's not going to get what they want. You just sort of have to understand that that's part of the development process. And for me, this is the first time taking on a project of this type of scope in a quasi-production way with multiple environments, multiple languages being used, mock requirements. That was a real important learning moment, just to realize that this is just what it's like. And even up to today, when I was working on some demos, there were some things that fell apart that I kind of wasn't, I thought that they were already working. And so I had to stop recording and fix it. And it's, not necessarily the funnest thing in the world to do, but it's part of the process. So that's just some reflections on this. If you've made it all the way through the video, I appreciate you taking the time. Obviously I'll put my contact information, uh, in the description, but I'm available from direct message, etc. There'll be a link to the code and some more information about me. As I said, this is a portfolio project for some upcoming job applications. So it's meant to demonstrate sort of where I'm going with becoming someone that creates cloud solutions for customers. And hopefully this has been a good demonstration of that. Thank you.